Okay, so the question is about to calculate the pH. So you want to know the pH when you use the 22.15 milliliters of the 0.104 moles of the sodium hydroxide to titrate 25 milliliters of the HClO. And you want to know the pH at the equivalence point. So the first thing that we can calculate is from the first piece of information that during the titration, the moles of the sodium hydroxide that we have used, that's equal to concentration times the volume. So it's 0.104 times 22.15 over 1000, since it's milliliter and we use liter as unit. And that's equal to about 2.34 times 10 to minus 3 more. And again, we can write down the reactions. We use sodium hydroxide to react with HClO, and of course, will form sodium ClO and water. Looking at this reaction, you'll find the reaction ratio of sodium hydroxide and HClO is 1 to 1. And also for the sodium ClO is 1 to 1. That means the moles of the sodium ClO equals to the moles of the HClO equals to the moles of the sodium hydroxide. That's 2.34 times 10 to minus 3 more. And then from here, we can calculate the concentration of the sodium ClO, right? That's equal to the moles of the sodium ClO over the total volume, because the sodium ClO forms only when the titration performed. So that's about 2.34 times 10 to minus 3 more. Over here is mixing them together, you have 22.15 plus 25 over 1000 liter. So that's equal to about 0.0496 more. So we know in the final solution, right, the concentration of the sodium ClO is 0.0496. And of course, we want to know the pH of the sodium ClO solution. So what we can do is we can try to write down the hydrolysis equation. That is, you have the ClO minus interact with the water and will produce the HClO and OH minus. So we need to know the concentration of the OH minus to actually calculate the reactions, right? So for this one, we know the Ka for the HClO. You can find it in the table, which is 3 times 10 to minus A. And for this reaction, it's actually the Kb, right? ClO minus. That's equal to Kw over Ka. The Kw is a dissociation constant for the water. So that's 1 times 10 to minus 14 over 3 times 10 to minus A. So it's actually 1/3 times 10 to minus 6. Anyway, we can start, once we know the equilibrium constant, we can start making the ice table. So initially, you have this 0.0496 of the ClO minus. You don't have any HClO and OH minus. And there will be changes. X more ClO minus will be consumed, so at the same time generating X more HClO and X more OH minus. So in the end, you will have 0.0496 minus X of the ClO minus and X more HClO and X more of the OH minus. So we can write down the equilibrium constant expression that the Kb equals to the concentration OH minus times the concentration of HClO over the concentration of the ClO minus. That's equal to x squared over 0.0496 minus x, and that's equal to 1/3 times 10 to minus 6. And we can make some approximations. So it becomes x squared over 0.0496 equals to 1/3 times 10 to minus 6. So in this way, you'll find the x here equals to about 1.29 times 10 to minus 4. So now we know this is actually the concentration of the OH minus. So from here, we can calculate the POH first. That's minus log x. So that's about 2.89. And the pH would be equal to 14 minus POH. So the answer would be 11.1. That's it. Oh, sorry, it's 3.98, so it's 10.1. That's it.